Hi, Edwin. Hi, Sanders.
Hey, how you doing? Welcome back, everyone.
Yeah, so we are still doing good, and as well as participants are. But so I saw some slides. So are you going to present us again something?
Yeah, so I just put on the slide with all the instructions, but I also have a little demo that I want to do before we start. So it's about a small 5-minute demo, and then everyone can go on with the workshop. And but this is a really cool addition to the traffic control application that we've built. So if I can share my screen.
Yeah, it works.
There we go. So what I have done is I've started, just as you guys are doing in the workshop, I've started Dapr traffic control. So you see the traffic control service over here. You see the fine collection service and the vehicle registration service. And we have the simulation, right? So this should look familiar now for most people that are at least done with the first assignment. So this is how it works. You see all the entry and the exits, and you also see the speeding violations. But yeah, this is just logging, right? You see some log entries, and this is not very exciting. So Sander, he thought, well, we had to do something about it. So in the Dapper traffic control sample, there is also a visual simulation. And if I start that, this looks a little bit more appealing, because it starts a web application. This is an ASP.NET Core web application. And if I go to this endpoint, so if I open this localhost 5000, you will actually see actual cars driving. So what he did was create a simulation. This is running in JavaScript in the browser. And you see actual cars running. And every time a car drives under the entry, and if I scroll to the left, because I can also scroll here, if I scroll to the right, the exit cam, then these MQTT messages are sent to the traffic control service. So this is basically the same simulation, but now written in JavaScript and sending MQTT messages. And yeah, well, this looks way more appealing than just these log rules. So this is something that we didn't want to keep for ourselves. So at the end, we also have a link to the Dapper traffic control, and it's also in the workshop sample, and all the code is in there. So you can also look at that. But I thought it was a nice addition. So with that, yeah, I should say let's go back to the workshop, and let's see where everybody is. And like we said, just as in the first part of the workshop, if you have anything to ask, or if you have any achievement, if you have any assignment done, just post it in the Telegram chat. And yeah, have fun and good luck with the assignments.
Yeah, and at least one person has gone through the third assignment already, so
yeah,
it's looking good.
That.
Yeah, so I think most of the participants are around second or third assignment.
Yep.
So that's pretty good progress, and we have 1 hour ahead of us to complete everything, and that should be fully achievable.
Yes.
And am I getting it right that the application that you've shown, you basically can grab the JavaScript part of it, I mean the visual simulator only, and then configure it so that it actually sends the traffic to the workshop version that the participants are making right now, so that instead of the normal simulator, you can run the visual part and see everything with your own application.
Exactly, yeah. So that's possible.
Okay. But it will not work with the HTTP version, right? So
it does actually, but I have to look up the exact file that you have to change, because there's a service in there in the visual simulation which has both the code for HTTP as well as MQTT in it. So if you comment out the MQTT part and then you enable the HTTP part, then you can use it for the for the workshop up to the what assignment is it? The bindings.
Yeah.
Because initially the workshop works with HTTP, and then if you add MQTT binding, then from that point on, MQTT is used. I can share that in the chat. So let me.
Or maybe you can show that, Sander, where the code is.
Or I can just share my screen and show that to you, of course.
So I don't know.
So let me first clean up my desktop here and then and then share it.
Okay, so I will stop sharing now in Zoom.
Yeah, so if you can stop sharing, then I will take that over.
Yep.
Let me see. Let's go to screen number 2. I'm not sure if it's visible already. Oh no, I always forget. In Zoom, I always forget the last button to press to actually start the sharing. I don't know why that is. I'm so used to Teams nowadays because we use Teams in our organization that Zoom is always a little bit out of my comfort zone. But here I am at the Dapper traffic control. So there are actually 2 different repositories, right? So Edwin VW/Dapper workshop is the repository that you have been working in up to now. And we kind of hide this one from you because it contains the final solution. So if you want to cheat and look at the final result, you can go to Dapper traffic control. And inside Dapper traffic control, there is this simulation, which is the normal simulation. And there's the visual simulation, which is the nice animated one that Edwin just shown you. And if you look in there, then basically you can see that this is just a very lightweight .NET Core application, which basically does everything in JavaScript. And the way that this works is that we use this JavaScript library called Phaser. So let me quickly show you. Phase.io is the one. Oh, maybe just go to the home page. So Phaser is this really cool HTML5 library, which makes it really easy to, well, basically create games, but also these kind of animations, because it offers you stuff like animations, physics engines, sprites, all the stuff that you need to pretty easily create a simulation like that. And inside, I have to look for it. There is a, yeah, that's right.
Traffic control server, HTTP and MQTT.
There's an HTTP and an MQTT. So this basically is my MQTT implementation. So it just sends an MQTT command, and the traffic control service HTTP uses HTTP. And if you go into settings, you can see here on line 7 that I'm currently using the MQTT traffic control service. So that's on by default. But if you want to try to run this against the Dapper workshop and you're not up to the assignment where you implement the bindings, then MQTT will not work. And you can simply comment out this line number 7 and enable line number 8, and then it will use the HTTP traffic control servers. And that's that should work fine. I'm a little bit worried about this 5000. Is that the correct port, Edwin, for the traffic control servers?
No, probably not. So you have to look at the port numbers in the workshop.
Yeah, so find out the port number for the traffic control service and use that port number here, and that will work. We should definitely change that. So let me add that to my to-do list to fix that in the solution as well.
Okay, thanks for showing that, and I hope actually nobody would need the HTTP version because everybody do the workshop and have the MQTT up and running. I don't know, Edwin, if you have seen the question in the chat, like RabbitMQ pops up issue, the runtime error about some given key wasn't present in the dictionary. Is it something that you are familiar with during the workshop?
No, I haven't seen that before. Collect fine. Tryable error return from an app or processing sub event. No, I haven't seen that before. So it is in the find collection service. This is weird.
Does it continue to give that message, or was it just a one-time message and then it started working?
Yeah, let us know in chat, please. And yeah, we know there is a small delay between video and the chat, so do not expect the immediate answer.
Yeah. So let me see. I will look at the code now to see what that could be, but I haven't seen that I haven't seen that before.
So it's in define collection servers, and it's
I know.
probably when it's it's probably looking up something in dictionary. So the first thing, yes, it's repeatable.
That's weird.
So does it mean
So what
that
kind of dictionaries are we using in the collection servers?
That's why I think it's weird, because it's just it's the find calculator. Maybe it's the license key. Maybe. Let me see.
It might be helpful if you can post the full stack trace. That would be, at least we can see in which method and which controllers, etc. it's happening. So post a full stack into the chat, and that might ring some bell. And so while we're waiting, I had a question about, you mentioned in the beginning that you were doing this Eshop on containers in Dapr, and but then now you switched to another example. So why, I believe you, what was the reason why you actually stopped using Eshop on containers for the workshop, or it has never done as a workshop?
Yeah, it's a good question. So initially we were planning to use Eshop on Dapper in the book as a reference example, and then also do our sessions with it and give workshops on it. The problem with Eshop on Dapper for explaining just Dapper is that it's a fairly large, complicated solution, and it tries. So the original version Eshop on containers that it is based on tries to teach you a lot of things. So there is a lot of stuff around domain-driven design in there. There's a lot of stuff around messaging patterns. They use a lot of different libraries, such as Mediator, to show you how you can make sure that your services are loosely coupled. And all of that makes it more difficult to just focus on Dapr. So if you want to show what are some of the best practices of creating a microservices application, then Eshop is a great example to learn from. But if you want to show how to use Dapr and primarily focus on Dapr, then it's just too much stuff is in there, and you kind of lose focus, and it's more difficult for attendees to do exercises because they not only need to learn about Dapr, but then they probably also need to learn about all kinds of other stuff that's in Eshop that they may not have encountered before. So basically then we decided we need a bit of a more lightweight sample application. And we are also going to change that in the book, by the way, because in the book, each chapter is basically about a single building block. And then in each chapter, we used Eshop to explain what Dapr provides, or to give a practical example of Dapr. And we are switching it out there also. So in the next version of the book, which will be hopefully, if we've got time, hopefully next month or so, we will use this Dapr traffic control sample application to explain the building blocks. And then at the end of the book, we will have an entirely separate chapter purely on Eshop and approach it more from a reference case kind of way, right? Because those are two different things, I think. On the one hand, you want people to just focus on the Dapr building blocks and learn how to use them. And then on the other hand, you want people to learn about real world scenarios and what the impact can be of using Dapr in real world scenarios. And it's better to use two different samples, each focused on a single goal, than to try to put that all in a single sample. At least that's what we've learned so far from this whole process.
Okay, yeah. So because I took a look at the Eshop on containers. So not on the Dapr, but still it's a fairly large product, even though with a very familiar like business area, but still, this traffic control thing is also pretty familiar, probably. Maybe it's not too many such kind of cameras here in Russia, but still the logic is very easy and understandable.
Yeah, the logic gets kind of out of the way, and you can quickly find the building block and how it works. Whereas if you look in Eshop and you go to a service and you want to find where did we use the Dapr building block, you probably have to go through like 4 or 5 layers of indirection before you get to the level where the Dapr building block is used. And that just makes it more difficult to follow, as an example.
Yeah.
Okay.
And with Dapr traffic control, we can use the extensive experience of Edwin receiving speeding fines for our business logic. So.
Not anymore for the last 6 years.
Since you've got cruise control on your car, is that right?
Yep.
Yeah, but I don't
Good
think
idea.
Edwin's experience is like, well, from the business logic part of the application, so the receiving part is easy here.
That's true. That's true.
Okay, and I think we have our first participant coming up to the 5th assignment, so it's going pretty fast, isn't it?
Yeah, by the way, you guys
Yes,
are racing through this because usually when we
fast.
do this workshop, it's at a lower speed, lower rate. Yeah.
Okay, but well, people are
So excellent. Yeah.
motivated and focused. And also having it online actually has a good thing about, well, I see you sit with your own comfortable equipment with the large monitors, a second screen for instructions and one screen for the real Visual Studio Code, instead of like if I want to do it, I have only my small 13-inch laptop, which I have to alt-tab a lot.
Yeah, so by the way, at what assignment are you right now, Igor?
I'm just talking with you, so I'm at assignment number 1.
Oh, I thought you were using parallel threads to talk to us and do the workshop as well.
Multitasking. Yeah, I am multitasking. I can do it very well. That's my job, but it's not too good. I'm not too good in like being talking. And the problem is that if I start staring at my laptop, it will not be too good to talk regarding talking. So I have a lot of more things to ask, and I think it's a good time to just talk about Dapr while people are working. It seems like we are not like making them slower. Even if we do, it's not an issue with the current pace they have.
They're blocking us out.
Yeah. So the question was, like you mentioned, one of the building blocks, or at least the areas where Dapr can help and has the sidecar, not the sidecars, but the building block is the actors. And in my world, or in my understanding, actors are just some very lightweight thing. So isn't like a Dapr is a too heavy thing for the actors? Or is it like you have your application where you run multiple actors inside one Docker container, and then if they want to talk to other actors, then this is where Dapr is involved. Because I can't imagine a situation that each container is a single actor.
No. That would be bad. That would be real bad. Right.
Yeah.
No, I agree with you completely. Actors are a lightweight thing, and if you've got a big actor solution, you maybe have millions of actors spread around, each doing a tiny thing, storing a tiny bit of state. So the way that actors work and the benefit that Dapr gives you is you have a choice, right? You can either go with a library, an actor library, such as Akka or Akka.net. But then that's mostly tied to a specific language. So, for example, Akka you use in Java or probably Scala. Akka.net is for .NET. The nice thing with Dapr is that it's totally language agnostic because it all runs inside the Dapr sidecar. And the actor API is exposed via HTTP and gRPC. And so you can use it from any language. So if you have a microservices environment that's polyglot, that uses different languages for different services, then now they can use the same actors. So that's a benefit that you get from Dapr. Now, about the hosting of the actors, what happens is that when your application makes a call to an actor, the application actually calls into the Dapr sidecar. So your application tells the Dapr sidecar, I want to invoke an actor. The actor ID is XYZ. And the method I want to call is, I don't know, process some item. And then the Dapr sidecar will activate an actor for you if it hasn't been activated yet. And this activation is being done by or I should say, where the actor is activated is being determined by a Dapr system service called the Dapr placement service. And that placement service keeps track of all the actors in the solutions. And it makes sure that they are distributed evenly across your Dapr sidecars. So let's say you have, I don't know, 10 microservices running in a Kubernetes as a single solution. So that means that each of those microservices will have its own Dapr sidecar. So in total, you will have Dapr instances running, 10 Dapr sidecars running. Now let's say that within your application, you've got a total of 1,000 actor instances. The placement service will basically make sure to distribute all those actor instances across your Dapr sidecar. So each Dapr sidecar will host approximately 100 Dapr instances. And the nice thing about that is that the placement servers can keep track of the health of your nodes. So if one of those nodes goes down or if your pod crashes, then all the actor instances that were running in that sidecar will be redistributed across the other Dapr sidecars. So it's definitely not a one-to-one where each single actor needs their own sidecar. It's like one-to-many where each Dapr sidecar can host a lot of actors, but you don't need to worry about where one single specific actor instance is being hosted. That's all being determined by the placement service.
Yeah, and in the Dapr traffic control sample, there's actually an actor-based implementation. So as you might know now, in the traffic control service, each vehicle, the state of each vehicle is being stored in the Redis cache. But there's also an actor implementation, and then for every vehicle that is registered, a new actor is created. And the state is being registered by this actor. And then once the vehicle drives under the exit cam, it will send that message to the actor with that license number as its ID. So there are a lot of actors then up and running for every vehicle one inside the traffic control service.
Okay. So there are some issues with ports in the chat.
Yeah, I saw that.
Okay.
So maybe it's already running?
I'm going to check in the Eshop repository because there was a similar issue a couple of days ago with Eshop on Dapper with a port being in use but not being visible in Netstat. So yeah. I'm going to try to find out how they solved that one because I don't remember by heart.
And while you're finding, we have a little bit more. So the PubSub part, I believe that's the assignment number 3, right? Okay, maybe it's not that important.
Yeah, it's true.
So the PubSub. So in this case, we are just subscribing to the messages and that's it. So, but I believe Dapper also supports a lot of kind of all these messaging patterns. Let's say like you can send messages to organize requests. Well, you don't technically need request reply, but I know that say RabbitMQ has this request reply on top of the message queues. So, and all the Dapr building blocks, do they support all kind of these things? If I have already a system running that uses that.
No, that doesn't support it out of the box. Of course, you could implement request response yourself, right? By creating some kind of a reply topic that you listen to, and then you send the message, and then you expect the reply on the reply topic. But there's no semantics for request reply with the pub/sub building block within Dapr, out of the box.
Okay, so it's just a simple like a topic where you subscribe to the topic, and then whenever something comes, you just respond or react.
Exactly.
It is exactly publish, subscribe. So you have one publisher, and you could have multiple subscribers. They are working on, for instance, things like filtering or routing messages. And you could also, of course, there is also a whole system of what we use scopes within Dapr. So that you can also specify which services need to listen to which subscriptions, so to which topics. So you can divide your messaging over your services a little bit with Dapr, but that's it basically. And it's all pub/sub.
Okay, that was my next question. Like, if I know that only half of my application is interested in a given topic, then why? So I want to hint this to Dapr so that it doesn't send these messages to other sidecars, even though they may have subscribed to something else. Okay, so looking through assignments, in the assignment number 4, which is about caching and Redis and other things, I found a statement that the Dapr can help you with, of course, with like simple key value access, get the value by key or store some value by key, but also to help with the bulk operations, like bulk CRUD operations, as you wrote. So will it just aggregate something and then send it to the real service, or what did you mean actually by these bulk operations? Because, it's not too clear for me, but I'm not an advanced user of these services. What can I do in the bulk mode, and how Dapr can help me? If it's just a simple proxy to what the underneath service supports, or it's just some business logic in the Dapr itself.
Yeah, but I'm trying to understand what you're asking, because this is about state management, right?
Yes.
Yeah. So
I was just reading your Git page, the README page.
Yeah.
No. I can answer that, Edwin, because the state management, I've been working more with the state management than Edwin was, but I was trying to find that netstat error, which I can't find. Annoying.
We can take it later.
No, it's fine. It's fine. So the bulk operation enable you to just be more efficient with saving and loading data from the state store. So the state management block basically provides you a key value API, right? Mm-hmm. So you just store key value pairs. So in this case, I don't know what's actually the key. It's probably the like the license number and the point of entry or something like that.
Yeah.
And then the value.
Application ID.
Right. So you store typically pretty small amounts of data. And then in Eshop, for example, we are storing the shopping basket using that key value API. And then I believe I've chosen as a key like a combination of the customer ID and the article number. And then in the value, you can store the quantity or something like that. But some of the times, sometimes you don't want to have to store each key individually, but you just have a bunch of keys that you want to store in one single command to the sidecar. And then you can use those bulk operations to store them in bulk and also retrieve them in bulk, just to have a little bit of better performance.
Okay, I got it. So it just, the way to optimize things. And talking about optimizations, you already mentioned that, of course, it's all these architecture with Dapr is not intended to be used for like very high performant applications where every millisecond counts, because there is a small overhead from all these invocations via the sidecar. Right. The question is about observability. Will I see all those like extra hops between my main container and the sidecar in the tools like Zipkin? So I will see like, okay, this was the duration of the call to the sidecar, and then the sidecar called to another sidecar, and then another sidecar called something else, and then maybe there was some service discovery on the source sidecar, which also took some time. So is it all visible? so that I can...
and not entirely at the level you're describing, because, for example, the service discovery will not show up. So it's a little bit high level, but it's still pretty fine grained. So it's actually fairly cool, because without having to write any code, if you look at the final Dapper traffic control sample and then look at Zipkin, you can see the nice threads of, hey, okay, I'm making a service call and then I'm doing pub/sub and I'm writing something to state. So all those interactions that you're doing with the Dapper sidecar are showing up in those distributed traces. And I believe in the Dapper traffic control, actually, then those are fairly short because it's only short interactions. But in Eshop on Dapper, you have much longer running processes which involve like 3 or 4 services. And then especially you see that benefit of that automated distributed tracing, and you can exactly see what's going on and what services are communicating with each other and the Dapper sidecars.
Yeah, and next to that, so if you look at distributed tracing, that's all about communication between services. But of course, there's a lot of additional metrics that are generated by Dapper, so also by the Dapper sidecar, and actually also what you call the lookups, the name lookups, but also things around mutual TLS, because there's mutual TLS between the services. It's a secure channel. But if you start looking at open telemetry, that is an open standard for sending messages or for sending telemetry to some backend. For instance, Grafana. You could use Grafana for getting insights into those metrics. And then you can see a lot around performance, resource utilization of the Dapper services itself. So you can see the placement service, you can see, all the services that we have talked about. You can get a really clear view on how they are performing, how much resources they are utilizing on the cluster, and it's all viewable.
Okay, thank you. Actually, I have a question to the person who has troubles with the port numbers. I assume you probably use Windows, because I do have found this issue that actually Hyper-V is playing tricks with your port ranges, and some port ranges might not be available for you when you use it.
I had the same thing.
That's something Edwin ran into. I also found the Eshop on Dapper issue, which was basically the same. And well, the bad news is, there's good news and bad news. So the good news is that person fixed it. The bad news is he fixed it by rebooting his machine. So yeah, that's always something that you can try. That will maybe on a reboot, Docker will choose a different port range if you're lucky, and then the port will be free again. So it's a Mosquito container, right? So Edwin,
yes,
are there is there lots of settings you have to change if you want to change that?
Actually, if you want to fix it, I already ran into it sometime. Then you actually have to disable Hyper-V on your machine, and then claim the port ranges yourself, and then restart it again. So it's quite an extensive thing to do, and like Mosquito is the one service that is most awkward to fail, because you have this configuration file going on. So let me look into what we can do here to circumvent this issue.
Can we change port numbers to use some different ones?
Yeah, we could. So if you look at the code and you look at the instructions, if you use a different port, that is available, but then you also have to change the configuration file of Mosquito. So let me look into let me see. I'm getting the workshop here, because I think it's doable to make that happen.
Can you share your screen maybe?
Let me first look, because I'm just scrolling like a madman throughout the code.
Developers looking for the kind of issues or solutions is not the best entertaining thing.
No. Frantically searching.
As the Okay, and the
Let's
mosquito
see.
is
Here we
the...
go.
Okay, something was found.
Well, there's a screenshot with some excluded port range, but some of the stuff is in Russian, so
I can translate.
Yeah.
So the columns are
if you
like
look,
the start port and the
yeah, I
end
see it.
port.
right, yeah, that makes sense.
1865 to 1964. That is where 1883 is within that range. So
Yeah.
this is the one that is let me see if I have the command here. And it's a really weird thing because I have been working with this for a long time, and then all of a sudden I couldn't. It was a different port for me, but all of a sudden they were excluded by Hyper-V. So what we could do is this.
So Microsoft is just rolling some update, and then whoop, and your ports are excluded because, well, I believe it should have been like some kind of a static configuration. Like, okay, these ports are for some reason are required by Hyper-V, so that's it, and everybody should have them identical.
Yeah, it's weird that it's dynamic like that. You don't know what to expect.
So I will paste the command into.
And surprisingly, my list is at least twice as long as
Yes. Yes, and I also have the idea that Hyper-V, every time you start or stop it, it will take another range, or it will take some range. Because, like I said, I've had this issue without changing anything on my machine. So every time you start Docker or whatever, it will do something weird with these ports. I don't know, by the way, if this command actually needs you to reboot your machine. So be aware of that. But I guess it could be done without a reboot. And now you just exclude the port range. And then because you disabled Hyper-V and then exclude it for yourself, you have to do this in an administrative terminal. Then Hyper-V will stay off that port.
Okay. And we have Mosquito up and running, actually. So something... Yeah, but I think... Yeah, you changed the port to B1993.
You changed the external port. Yeah, that's also...
Yes.
And that works as well. I'm not sure where do we have the port number in the solution, Edwin, just so we...
yeah, we have to look at the...
miss anything on that side.
So this is assignment 5, right?
Yep.
No, it's the assignment 4.
So I guess it should only be the only port number that you should change in the Dapper traffic control would be in a Dapper component configuration file. Because in the binding configuration file, there you define where Mosquito is, and that's the only thing that should contain the port number, because all the other communication is being done through Dapper using that binding.
But there is the configuration files that those have the port in it.
The configuration Mosquito has its own configuration files, which also require the port.
So entrycam and exitcam.yaml, they have a URL in the metadata that says MQTT localhost 1883, and now you should use
1993.
1993.
Okay, so the feedback is here: two YAML files and MQTT traffic control service need to be modified.
Yeah. As far as I can see, that's the only one. Oh, and also in the code. So in the...
Maybe you can share the screen
in the traffic
now.
control service.
Yeah.
In the proxy.
Maybe
yeah, well,
easier.
it's just change everything. Every time you see 1883, you have to change the port number. Yeah,
just do a global search and replace on your entire system.
No, just when you walk through the workshop.
Yeah.
Okay, and talking about MQTT and the IoT in general, so I'm not too much into the IoT world as such, and I think MQTT is like the main protocol for all those IoT devices, and I worked a little bit with it via Azure, what's called IoT Hub, I think. That's where it accepts the MQTT. So again, the question is, it's like the Dapper is just an abstraction over those services, and it will just handle all the traffic that comes in. Because as far as I know, the IoT traffic can be very heavy, so to say.
Yeah, definitely. So in this case, we are using a binding to just accept. So basically, we're doing kind of PubSub, but with an MQTT broker, right? Because Mosquito is the broker, and the simulation publishes MQTT messages to the broker, and then we want to subscribe to those messages. But Mosquito is not a supported PubSub component of Dapr, because, as you said, it's not really for enterprise messaging. It's more like this IoT thing, where which often used in IoT scenarios with devices trying to send some data to the cloud or to each other or to a PLC. So in this case, actually, the overhead that Dapr brings is pretty low, because it simply subscribes to that MQTT. What's it called in MQTT, Edwin? Is it a topic also? Do you call that a topic?
I guess it was a topic, yeah.
Yeah. So the overhead's pretty low. So I think that we didn't do any performance testing on this, but I think you could get quite some messages through there per second.
Yeah. By the way, I have shared my screen now with the appropriate rules that you need to change. So maybe if you put my screen on. So I'm now in the workshop in assignment 6. And then at step 3, you have to create an entry and an exit cam. So you have to change this port to 1993. And also if you go down, and also this one, of course. And then if you go down into the code, you specify also a port number here. So this is in the MQTT traffic control service proxy. You also have to specify the port here.
Okay. And we have the first person who is up to 6 assignments. So the final one is there. So it's
Nice.
cool.
Good busy.
Good busy.
Yeah.
Yeah. That's how we roll.
Now, I think the 6th assignment was exactly about output bindings, if I'm remembering it correctly. And I had the question about output bindings. I mean, it abstracts what you can do. Like sending email is just like calling an HTTP endpoint, kind of, and then sending some extra data. So my question was, how is it done? So as soon as you introduce any kind of abstraction, you probably is trying to like make sure all services look the same. So, and some services may have some advanced capabilities or some very customized behavior which you can use if you use the native SDK for these services. But if you abstract them via Dapper, then you may lose this ability, or it still like depends on how the component is written.
Well, yeah, it a little bit of both. So it depends on how the component is written. But in the end, you're totally right that the Dapper abstraction, so the API, that it has to receive a certain format of the message. And that is what you can do with an output binding. So if a certain service that you want to abstract with an output binding has certain behavior, and you have to configure that, or you have to send additional information, it should be in the message that you send. So that's all that you can do.
But then it's you as a kind of, we already have the output. Okay, so maybe I'm not totally understanding it here. So the output binding is a kind of a standard component, but then you add some code on top of it to adapt it to some, because if I want to create an output binding for my own in-house custom service, like, I don't know.
You could do that.
You could create it, and then you create an output binding component. So the binding is a standardized Dapper API. So it's a building block. It's the bindings building block. And then once you have called it, you configure a component, and this component will abstract the service that you want to call.
Yeah, but so I think that there are like different levels of abstraction going on here, because with output bindings, you are always talking against the Dapper API, right? So in the case of output bindings, you're talking against the Dapper output bindings API. And that API is still pretty dynamic. because it basically says, give me a name of a binding, give me some data, and give me give me some optional metadata, and then also give me the name of an operation you'd like to invoke on that binding. Yeah. So, for example, the SMTP binding that Edwin created could support an operation called send mail, where if you call that operation, it would interpret the data as the body of the email, and it would get the subject from the metadata of your call. So
that's exactly what it does now. So the operation is created.
So I guessed that correctly.
Yeah, you guessed it correctly. And to come back to you, if you look at SMTP, because SMTP is not calling just an API, it is actually using the SMTP protocol to send the email to the SMTP server. So that's a proprietary protocol. And you don't have to learn that now anymore. So that's the whole idea of this output binding. I can now do an HTTP call with, just as Sander said, the body as the data, and for instance, the recipient and the subject in the metadata. And then when I send that to the Dapper building block, it will use my SMTP component to actually talk to the SMTP server using the SMTP protocol. So I totally abstract SMTP as a protocol, and I can just now call it as an HTTP API.
Yeah, and the configuration of the SMTP server to use is the configuration of the sidecar, basically.
Exactly. So if I have
component configuration file,
yeah. So I have to know where is my SMTP server located. So what's the host and what is the username and the password to connect to this SMTP server? And you have to connect with this username password as SMTP protocol prescribes. And this is now completely abstracted from me. I don't need to know anything about the SMTP protocol. I just configure where is it, what is the username password, and then I can send emails using the Dapper output binding. And maybe another example would be, for instance, sending a tweet. So that's the same thing. I just want to send a tweet as a body. I have some metadata, and then I send it to the Dapper binding, output binding, and then the Twitter component will actually know the Twitter API and send that message to Twitter. And then you can configure that using the component configuration file.
And I think the important thing to note about bindings is that they offer a generalized API, but they are not always interchangeable with each other, because the SMTP binding may use the data as the body, but the Twitter binding may use some metadata for the body, right? So bindings would something you use to abstract some complexity. I don't want to learn the Twitter API, I just want to tweet. So when I use that binding as an intermediate layer, I don't need to learn that API anymore. I can simply call that binding. Whereas other Dapper building blocks, for example, the pub/sub building block, they are much more geared towards interchangeable components. Because if you look at that API, that's a much more specific API than the binding API. It's an API that specifically describes how do you publish, how do you subscribe. And because that is so specialized, every component basically behaves the same. Whether I've got RabbitMQ or Kafka or, I don't know, Azure Service Bus, maybe Event Hubs, stuff like that, they all behave the same. And of course, anytime you add an abstraction layer like that, you can only offer the common denominator, right? So you lose some capabilities. For example, with Azure Service Bus, there's this great feature called sessions, where you can make sure that messages that kind of belong to each other, or you want to process as a single unit, stay together and are being processed by the same subscriber. That is not a feature that's being surfaced through the Dapper API, so I cannot use that in a Dapperized application.
Not yet, by the way.
Not yet. Of course, there's a large wish list on GitHub of stuff they want to include. For example, having time to live on messages or scheduled. But of course, then the problem becomes anytime you add a capability like that, all of your pub/sub components should be able to implement that capability. Because if they don't, then you get into this weird situation of some pub/sub components supporting feature X and some pub/sub components supporting other features but not X. And that makes it really difficult again, because then your abstraction breaks down. So it's going to be interesting to follow this process and see what kind of balance they find. Because at some point, you probably have enough features that will satisfy like 80% of the scenarios and can be implemented by all the message brokers. But there will always be situations where you need some specific feature of a message broker for some reason. I think one of the ways that the team thinks about it is that that 20% of the situations where you need something really specific from your infrastructure are probably not the generalized enterprise applications. Right? They're probably, maybe it's an IoT-like situations where you need to process millions or billions of events, and you really want to tune that messaging infrastructure to do exactly what you want and how you want to use it. But for each such project, there are like 10 or 20 projects that are just an office worker is adding in some forms, and there's some pub/sub going on in the background to start a workflow or a business process, and the email needs to go out, like more easy generalized applications. And I think that's where Dapr really shines as a tool for enterprise developers who don't want to worry about all that infrastructure and who don't need to tune that infrastructure in the best way possible, but who really benefit from having an abstraction layer over all of that, so that they can focus on writing the actual business logic and providing value to their customers.
Okay, that was very definitive answer to my question. And the one thing came to my mind while Edwin was talking, like you are replacing the call to the very complex SMTP protocol with a simple HTTP call. But the truth is that you're not really calling HTTP manually, right? You always use SDK. Is that like the right approach, or there are times when you really want to do the HTTP calls to Dapper sidecar?
You can do both. So it is more around how easy do you want to program, right? So the SDKs are, most of the time, they are a little bit more higher up in the abstraction layer, so they abstract some stuff away, and you can use the SDK if you you can choose, right? So you can do it just with HTTP, because if you have, for instance, .NET, you can use the HTTP client to call the Dapper sidecar, or you can use gRPC. So you can use both of them, but it's more or less up to you what you want to do. And if you are in an environment that doesn't have an SDK for Dapper, then that's the only way to do it.
Yeah,
and that's really interesting, because with Eshop on Dapper, as Edwin mentioned earlier, we use Envoy proxy.
Yeah.
And for all the requests coming into Envoy, we want to route them to the destination service by using Dapr service invocation. And the reason we want to use Dapr service invocation from that Envoy proxy to the backend servers is that we then get that encrypted channel with MTLS, and we get all the observation. So that's very nice to have. But of course, Envoy is just a process with a configuration file with a lot of YAML in it, and we cannot use any SDK in there. No. So then it's very nice that service invocation API is reachable via HTTP, because we basically just need to transform the incoming URL to the correct URL on the Dapper sidecar, and then make that request, and now we've got service invocation up and running.
And then there is a question, as soon as I'm calling HTTP endpoints, there is a question, should I use like some resilience here, like use poly? Can the HTTP request to the sidecar basically fail?
Yeah, it can definitely fail. And if you use service invocation, then you get some retry logic out of the box. So if the,
Yeah, but
No.
it
I
depends.
I should change my answer on that
Yeah.
one. So if the call to the sidecar fails, then you will get back an exception. And it's kind of, if you're using the SDK or one of the SDKs, it's kind of up to the SDK if it has built-in retry policies. And I'm trying to think through the SDK code in my head, but I believe in the .NET SDK, there is no built-in retry policy. So if you cannot deliver your...
You're not entirely correct, because in .NET, but that's
Yeah.
a particular part. They reuse the HTTP client stack for doing the actual service invocation, and the HTTP client stack in .NET has a natural extensibility point for plugging in something like Poly, and you can still use that with
Oh yeah,
the
but you
.NET
have to
SDK.
do that yourself, right?
Yes,
So-
this is the whole Ryan Novak thing that he was working on.
No,
So
exactly. So
Yeah.
so if you have to do some work yourself to protect against it. But on the other hand, if your call makes it to the sidecar, then the sidecar makes the request to the other servers, right? That you actually want to call, and there is a retry policies built in. Now the chance that your call makes it to the local sidecar is very high, because the sidecar is always running on the same machine as your application is. So the only time that call would fail is if your sidecar is like down or should be restarted, stuff like that. And of course that could happen. And then if you're running, let's say in Kubernetes, then Kubernetes would probably just take down your whole pod and create a new one.
So Kubernetes is actually observing both containers and kind of killing the pod and restarting it, or provisioning a new one as soon as either my main container dies or the sidecar container dies.
Exactly.
Yeah, that's correct.
Okay, so the final assignment was about secrets, and I think we've got a little bit of time to talk about it as well. So the secrets, as I said, my secret retrieval is now a plain HTTP call to the, again, sidecar, and then sidecar goes into whatever secret storage you use using HTTPS, TLS, and everything. And kind of, I was a little bit like, getting the secrets via plain HTTP is maybe not that secure, but the traffic actually never leaves the container, the pod, not the container.
That's right. So the pod is considered a security boundary, right?
Yeah.
So and you can tighten it down even further by using API tokens. So if you're concerned about maybe other containers that you're running in that pod, because if you've got another, let's say you've got your application container, you've got a Dapr sidecar, and for some reason you also have another piece of maybe common off-the-shelf component running also in a container in that same pod, then that other application also has access to a Dapr sidecar. A different scenario is where you, for some reason, I've seen some people talk about this who wanted to do this. They want to expose their sidecar API outside of the pod, so that external applications could call into that sidecar. So those are specific scenarios, but the point is that that sidecar API is totally unprotected. Just as you say, it's just HTTP. There's no protection at all. So in those cases, if you're concerned about that and want to tighten it down, you can use an API token authentication. And in that case, you generate an API token, you configure it on the sidecar, and then the sidecar will only allow requests that have that API token in a header. So from that point on,
wasn't it exactly the scenario with this envoy thing? Because you're actually calling, as far as I understand, into the sidecar or into the Dapr, so that it delivers things then whenever it's necessary. Or the envoy was running inside a container and it was not like an external API access.
Yeah, so it was not external API access, because with Envoy, we've got Envoy running in a container in a totally separate pod. So in that Envoy pod, we only had Envoy running with its own Dapr sidecar. But Well, it's interesting because one thing we could have done instead of having Envoy there, we could just have a single Dapper instance, being the API gateway, expose that port, and then from the client application, call directly on the Dapper sidecar and tell it to do a service invocation on one of the backend services.
So theoretically, if you have your like security perimeter around your containers and you run multiple pods and they are all inside the security perimeter, then technically you can have a gateway at the edge, and then you can call directly into the sidecar without kind of worrying about non-encrypted traffic because you are inside
and I would say that solution that you describe is a much better solution than just exposing your Dapper sidecar to the outside world.
Yeah.
Because for me, it's really it should be an implementation detail of your solution that you are using Dapper internally, and you shouldn't use that as a means to connect to other systems. So just as you say, just whenever you want to do something like that, just put a gateway like an Envoy or an Nginx there that accepts the response, and then route that to your internal Dapper sidecar. That would be a much better solution. Yeah.
Okay. So it seems like the progress in chat is fairly good. No more questions, and participants are progressing, so we can continue our chatting. And I saw this slide, which is now, as you said, 2 months old, with like, I don't know, hundreds of different kind of components or the building blocks. So, and the question is, whenever I have such a huge choice, I often like worried approaching it because, well, I need to make a choice. So the question is, do I really need, is there any options like points of choice when you're choosing these building blocks? Or is it like, okay, I need PubSub, fine, I just use the PubSub building block. And then, of course, I need to choose the backend service, whether it be like Azure Service Bus or Kafka or something.
Maybe because you need to make the correct distinction between building blocks and components.
Components, yeah.
So building blocks are only like 6 or 7 of them. And one of them is like PubSub. And then if you choose to use Dapper PubSub for your asynchronous messaging, then you can choose from that larger list of components, of PubSub components. And I think there are maybe 12 or something like that.
Yeah.
And then you can choose which one you want to plug in. Now, the nice thing is that if you're at a point in the project where you don't care about what kind of infrastructure you're going to use yet, you maybe want to defer that decision until later in the project, you can just pick one. Just go with Redis, and you've got PubSub, and that's good enough to develop against, to test, and then maybe later on, when you've got better requirements of what the volume is going to be, of what what your budget is going to be, then you can decide on your final infrastructure, and then you can just change to that just by making that configuration change.
Yeah. So the distinction between building block and component is very important, because the building block basically defines the API, the Dapper API. So the building block defines how am I going to do PubSub, for instance, and that's always the same. And then you just plug in the component for the message broker you want to use. So Nets or RabbitMQ or Azure Service Bus. So there's no difference there. And this is something that also, just as Sander said, this is one of the advantages of Dapper, because if we do a project without Dapper, we have the same choice to make. Are we going to use RabbitMQ, and are we going to use Azure Service Bus? And those choices are always made using, okay, what are the costs? What do I already have? What is the licensing model? All that kinds of stuff. Those choices you still have to make for your organization. But now from a developer perspective, I don't have to create an abstraction layer anymore to make sure that I can change my broker later on. I just leave it up to Dapper, because I can always tie to the Dapper API for PubSub. And if I do that, I can then use all the brokers that are available for where a component is available for Dapper for the PubSub building block.
Yeah, while we're on the topic of PubSub brokers, there's actually a pretty nice example in the Eshop case, because Eshop on containers supports both RabbitMQ and Azure Service Bus. So the idea is that if you run locally, you can just use RabbitMQ, which can be containerized. And if you want to use Azure Service Bus in the cloud, you can also do that, but that must run in the cloud. So if you're using Azure Service Bus on a real project, it may actually be pretty useful for developers to be able to switch that out for RabbitMQ if they want to run it locally. So the Eshop on containers original solution uses or has an abstraction layer, and they had to code that by themselves. And that is like 735 or so lines of code. It's not really a lot of code, but it's the kind of technical clue code that you can get wrong very easily. And it's fairly complex code. So we ripped all of that out and we changed that with just like 15 lines of Dapr code to just call the Dapr component. And the end result was that now we've got a much easier to maintain code base, and we've got even more choice for brokers, because now we don't only have those two implementations, but we can use any Dapr pub subcomponent that's available.
Mm-hmm. And the related question, you're fully correct that I'm an architect. So at the beginning of the project, usually what developers go and ask, okay, what kind of things we use, what kind of products we use for messaging, for PubSub, for everything. And as soon as I introduce yet another thing, even though it's an abstraction layer, Dapper, the question is, Dapper supports a hell of a lot of different components, but is it true that all of them are identical? Can Dapper influence what component you actually choose? Because it works a little bit better with some of them. Because, I don't know, the component is written better for, I don't know, RabbitMQ versus...
It might be because at the end of the day, it's an open source project and there are a lot of different contributors. And of course, there are reviews being done, and the maintainers also have a good look at the quality of submissions. But that could certainly happen, right? I think at this point, if you look at the components, most of the components are a fairly thin wrapper around the actual product. So I don't believe there's a lot of difference in performance by either using RabbitMQ or Azure Service Bus. I think that most of the performance differences will come from the underlying infrastructure itself. So just in general, is RabbitMQ better performant as Azure Service Bus, for example? But yeah, we're talking about open source with a lot of different developers, so that could definitely happen in the future. Yeah.
Okay, maybe I think it's now time to actually ask all our participants to drop a message in the chat where you are. Of course, you will be able to continue after we are done, because, well, you just take your own pace and complete whatever you can complete in your own time. But it would be good to know, just at least to have some statistics about how far you are. So please send us a small message, maybe only a number would be enough. That would be also good. And so how was actually your feeling? We were chatting all along. So
we always love talking about Dapper. So.
Okay. Is there actually anything that you may want to share in the last minute or two about the topic that I haven't asked you? I don't know, some important thing I missed, or...
Well, we've talked about a lot, so we covered a lot also because we have a lot of building blocks in the workshop. No, nothing comes to mind right now. I don't know if you have anything. I might have a slide with some resources, so maybe if I can share my screen for a little while.
Yes, that might be good to share. And I will also I'm just going to paste in the URL for the final solution, so
it's also up on the slide.
But I think you've covered it fairly well with all the questions you fired at us, Igor.
And I have some more, That's my job.
You know where to find us.
No. Yeah, I know where to find you, and that would be actually the Zoom discussion zone. I think we got to go there because that's where the participants will have a chance to finally enable their cameras and actually talk to you and maybe ask questions directly. if something went
sounds
wrong
good.
or their experience, what it was. So that is that would be useful. So that's the way. That's where we will go after the completion of the online part. So yeah, I
cool.
see the
And-
resources are on the screen. Yeah.
yes, and also a big thank you, right? So everyone participating in the workshop, thanks for coming to this session, and happy Dapperizing stuff, I would say.
Yeah, thanks a lot.
Yeah, we will definitely continue using Dapper, trying Dapper, and who knows if Dapper evolves in well, I don't know, in the next year. Then the next year we probably will invite you again. Who knows? Maybe even physically.
Hopefully in person.
Yeah, hopefully.
Yeah.
Hopefully
Yeah.
in person. Yeah.
So that would be good.
Yes.
Hi guys again. Let's finish talk. Thank you for a very interesting workshop. Bye bye.